Okay. Can you see the screen, students? PPT?
Yes, sir.
Okay. Okay. So IPsec, yesterday I have given you a basic introduction to IPsec, which layer it works and which layer it protects. Those things I have given the information. So okay. So where to provide security application layer? I think this we have done, right? We have completed. Yeah, IP security basically have three functional areas, students, like authentication, confidentiality. Any security protocol you take, authentication and confidentiality will be there definitely. No uh, doubt in that. So authentication, there is one protocol called authentication header protocol, which basically runs for IP sec. Then for confidentiality, it is ESP protocol. We will see these two protocols in detail later. So in authentication, what is basically uh, yeah, I have already discussed this. I think no need to discuss it again. Confidentiality, as I said you, there is another protocol called not ESP. Okay, so and one more major function of IPsec apart from authentication and confidentiality is key management, secure exchange of keys. As I said you before, IPsec is not a single protocol. It is combination of multiple protocols providing different features to the packets which are being transmitted. Is that clear? So key management plays a very important role in IPsec, and this IPsec uh, uh, platform will do the key management effectively. Is that clear? So secure exchange of keys, because any protocol, if you consider exchanging or any, say for example Kerberos, if you take, that is not a protocol but it's a procedure how packets are transmitted, right? Similarly, IPsec is also a procedure. Okay, if you take SSL, it's combination of multiple protocols. SSL is also, so IPsec is also similar to that. But whereas compared to SSL or Kerberos or any other security services, IPsec provides a very good key management strategy. Is that clear? So that's one additional point in IPsec. We will see later how IPsec provides this key management. How it will do the key management, we'll do it. We'll see to it later. So IP security overview, Internet Architecture Board IAB in 1994 report on security in Internet architecture. So identified the key security mechanisms to secure from unauthorized monitoring and control of network traffic, to secure end user traffic using authentication and encryption mechanisms. So IAB includes authentication and encryption as mandatory security features in the next generation IP. Is that clear? So IPsec is there for both IPv4 and IPv6, but how IPsec works for IPv6 and IPv4 have little changes, is little different. Okay, because IPv6 there is a big change in IPv6 and IPv4. So the same thing is carried over in IPsec also. Okay, so IPsec specifications now exists as a set of internet standards. Okay, so let us see what it is. Applications of IPsec. So what are the applications of IPsec? Basically, the IPsec provides the capacity to secure communications across LAN, across private and public WANs, and across the internet. Okay, so provides the capability to secure communications across LAN and WAN. What is the difference between LAN and WAN? LAN is basically a small network, local area network, whereas WAN is wide area network. So a lot of different networks are connected together and we term it as wide area network. Okay, basically some part of internet you can say, and across the internet. Okay, so IPsec is widely used, students. Secure branch office connectivity over the internet, secure VPN, very important. Okay, this is also very important application of IPsec. We all say sometimes we are working from home. How do we do that? If I want to connect to AUMS and do some modifications in the AUMS data entry, like entering the mark or taking the results, so all those things I cannot do it through public internet. Okay, why? Because public internet is not safe. Somebody can uh, 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 somebody can access my net account and make changes to the entered data. Okay, so to avoid that, we are using something called as VPNs, virtual private networks. Is that clear? So most of the work from home options, somebody is connecting to their branch office through a software, and that software we call it as VPN. Is that clear? So the VPN software which we are using to connect to AMS is Fortinet. I guess you will know about it. So through Fortinet, I will connect to the college, I mean campus network. And when I am in the campus network, it is like I can easily access the AMS server. It is intranet. When I am in the campus network, it is intranet. Okay, so that's how VPN works. Like how VPN provides security, basically it uses a concept called as tunneling. We will see to that later when we discuss about the different modes of IPsec communication. We will see how IPsec provides security through VPNs. Okay, VPN is basically virtual private network. You are connecting to your branch office from another place, whether it is your home or anywhere. So securely, is that clear? Not over the, you are connecting it through internet itself, public network itself, but nobody will get to know you are using the public internet, public network. Okay, so that's what VPN is. Secure remote access over the internet, same as VPN, students. Establishing extranet and intranet connectivity with partners, again that also is a part of VPN only. Enhancing electronic commerce security, e-commerce security. Okay, so these are some of the applications of IPsec. And we are using applications of IPsec every day. Is that clear? In many cases, we are using it every day, either knowingly or unknowingly. Principal features of IPsec: it can encrypt and or authenticate all traffic at the IP level. That means in the third level or in the third layer. Thus, all distributed applications, including remote login, client server, email, file transfer, web access, and so on, can be secured. Whatever the communication that you do through your system can be secured if you are running with IPsec. Is that clear? Benefits of IPsec: we are seeing all the above things. What we have seen is benefits itself, but let us go through again. IPsec is below the transport layer, that is in the network layer. The top layer is application, below that is transport layer, below that is network layer, below that is data link layer, and below that is physical layer. So IPsec is below transport layer. uh, in bracket it is TCP and UDP, because transport layer uses either any one of a protocol among TCP and UDP, and so is transparent to applications. IPsec is transparent to applications. We need to change software on a user or server system when IPsec is implemented in the firewall or router. Sorry, no need. Okay, no need to change software on a user or server system when IPsec is implemented in the firewall or router. It is very easy to handle, students. IPsec is transparent. That means how it is protecting your data, and there is no need for us to change any software on the user or server system when IPsec is implemented in the firewall. Is that clear? So IPsec can be transparent to end users, the same thing. So secure transmission is also possible with individual users who dial into the WAN. Such users workstations must be implemented in the IPsec protocol to provide security. Is that clear? So IPsec networking devices will typically encrypt and compress all traffic going into WAN, and decrypt and decompress the traffic coming from the WAN, wide area network. Is that clear, students? Or you can say internet. So, students, is the applications of IPsec, principal features of IPsec, benefits of IPsec, is it clear to you? Shall we go to the next topic where we'll jump into the protocols which run under IPsec? Do you have any questions?
No, sir.
Routing applications, IPsec can assure that a router advertisement comes from an authorized router. So what do you mean by advertisement, students? What do you mean by router advertisement? You remember we have discussed this in your computer networks course.
Yes, during the routing algorithms, one router will be advertising about nearby the shortest neighbor. Bellman Ford's algorithm, what is that? The other one of OSPF. Uh,
Which
yeah,
one?
in that one, the advertisements uh, concept came. I'm trying to recollect, sir.
Yes, you are right. So basically, router advertisements means either you will be using an intra-autonomous system routing protocol or inter-autonomous system routing protocol. If you are using intra, you will be using either OSPF or RIP or EIGRP, those kind of protocols. If you are using uh, uh, inter-autonomous system routing protocol, there is only one routing protocol called BGP. Is that clear? So RIP uses Dijkstra's algorithm and OSPF uses Bellman-Ford algorithm. Is that clear? OSPF is a protocol which uses Bellman-Ford algorithm to go for routing. Okay. So what?
Hmm, I that is another one, sir. OSPF uses link state, some algorithm, and Bellman is used
Yes.
by
Yes.
RIP protocol, I guess. Yeah, something.
Yes. Sorry. Uh, OSPF uses link state. Is that clear? And for link state, Dijkstra's is the algorithm. And
Yeah, Digitras. Yeah, yes, sir.
yes. And RIP is not link state, it is uh, link state and the other one,
Distance vectors.
yes, distance
Yes,
vector.
distance vector.
Distance vector, and that uses Bellman-Ford algorithm. Okay, so basically, distance vector is centralized and the link state is decentralized protocols. Okay, so those are related to routing algorithms. Now, advertisement means every router will share about its directly connected networks to its neighbors. Is that clear? So how it will share that information? Through an advertisement message. It sends an advertisement message saying that for me these are the directly attached networks, and it sends it to its neighbors. Is that clear? So that is called as an advertisement message, and it will be periodically sending these advertisement messages so that the neighbors will understand that the router next to me is still alive. Okay, so routing applications, what are the applications of IPsec in routing? IPsec can assure that a router advertisement comes from authorized router. Is that clear? When a particular router receives an advertising message, is it from the proper user, is it from the right or authorized router, or any unauthorized access is going to happen? So who will check that? Again, IPsec is providing that option. Okay, a neighbor advertisement or maintain sorry, a neighbor advertisement comes from an authorized router. Again, it will check. A router seeks to establish or maintain a neighbor relationship with a router in another routing domain. Is that clear? I think second and third points are almost similar. A direct message comes from the router to which the initial IP packet was sent. A routing update is not forged. So basically, whatever the messages that are exchanged between routers, so those messages are authenticated. Is that clear? If you are using IPsec. So what are the IPsec documents? Very important, students. What are the IPsec documents? Can be categorized into the following groups. The first one is architecture. There are 7 documents, I guess. 1, 2, 3, 4, 5, 6. Okay, 6 documents. So architecture. security architecture for the internet protocol. It will have these are the 6 documents, and the first document is architecture, and the document architecture contains security architecture for the internet protocol. Is that clear? Then authentication header, it's an authentication protocol basically. And second one is encapsulating security payload, ESP. That's what I was trying to tell you. It is basically this encapsulating security payload protocol provides confidentiality. Is that clear? Authentication header doesn't provide confidentiality. Encapsulating security payload will provide confidentiality, and to an extent it will provide authentication also. That's why some of the communications or some of the networks will use only ESP. Is that clear? Because ESP will provide confidentiality definitely, and to some extent it will provide authentication, but it cannot provide authentication as authentication header provides. Okay, because for authentication header protocol, it's the only job. Providing authentication is the only job, whereas for encapsulating security payload protocol, the main job is to provide confidentiality. With that, it will also provide authentication to very limited extent. Is that clear? So that's about the two major protocols, and they are also called as uh, documents here. That is authentication header and encapsulating security protocol. As we discussed earlier, apart from authentication and confidentiality, the major feature of IPsec is internet key exchange. Is that clear? How it manages the keys? Is that clear? The protocol which manages the key is internet key exchange, that is called as IKE. Is that clear? It's a very important protocol. We can say heart of IPsec. IKE is heart of IPsec because IKE is the only protocol which is used for exchanging keys in IPsec. So that is also another document of IPsec. Cryptographic algorithms, what algorithms are used will be documented here under the cryptographic algorithms. And the last one is other, one more document, other IPsec related RFCs dealing with the security policy and management information base content. Is that clear? So these are the 6 documents which come under IPsec, which you have to remember, students. Okay, so just a second.
Sir, exchanging key means?
Exchanging key means, say if you are using a session key for communication. Session key means what? It is a asymmetric, sorry, it's a symmetric key. Symmetric key means for encrypting and decrypting, you have to use the same key, right? So who is going to generate that key? Generally, we have observed there are 2 ways. One, the sender will generate the session key, and the session key encrypts the data, and that session key will be encrypted using the receiver's public key. Is that clear? So that is one way to protect the key. Like that, IKE will have some other mechanism to protect the keys while it is being exchanged. Is that clear? So if you want to know the public key of someone, how will you do it? Generally, you will visit a directory service. In the directory service, there will be certificates of all the other users in our network or nearby network. So we will see the certificate of that user. So that is basically exchanging the key. Is that clear? Because in that certificate, you can see the public key also. Okay. So how do you do that? Is there any other way, or how this IPsec will do it? It will do it with the help of IKE, Internet Key Exchange Protocol. Is it clear?
Yes, sir. And sir, one more thing from last semester, I'm saying, what is request for comment, sir? Like RFC.
See, it's a document. Okay. Say for example, all the protocols we have discussed, many protocols like HTTP, FTP, SNMP, SMTP. Many protocols are there. No, thousands of protocols are there. If you want to, like, we say TCP work like this, UDP work like this, but where do you exactly, where it is documented exactly? Is that clear? So there is something called as RFC, request for comment. It is basically a document about any protocol which is running in the internet, and that is maintained by different standards. Internet Engineering Task Force, is that clear? That will maintain this RFCs. Say for example, if any new protocol is developed in which supports computer networking, in that case that also will be added into the RFC once it is standardized. Is that clear? RFC is basically bunch of, or you can say it is a repository where you can find the documents of all the protocols. If you just type the RFC TCP, you can see it will give you the number, because every protocol will have its own number, and then you can use that number to completely study about that protocol. If you just type RFC TCP, that will give you the complete structure of TCP, how it works, how it was initiated, or the complete information about TCP you will get.
Yes, sir. Thank you, sir.
Okay. So you have carried this doubt from previous semester.
Sir, no, sir.
Okay.
I just felt not very related to this subject, so I kept postponing.
Okay. Better late than never. Okay. So Ipsec Services, two protocols are used to provide security: an authentication protocol designed by the header of the protocol, authentication header, and a combined encryption authentication protocol designed by the format of the packet for the protocol encapsulating security payload. That's what I told you, students. Encapsulating security payload protocol provides confidentiality for the data which you are sending. Authentication header protocol provides authentication for your connection. Is that clear? So, but I told you already, ESP will provide, that is encapsulating security protocol will provide authentication also to some extent. That's what you can see in the second point. The combined encryption authentication protocol designed by the format of the packet for the protocol. Is that clear? That is encapsulating security payload. RFC 4301 lists the following services. You can see, you can check in your Google what is RFC. Just type RFC 4301, you will see. Related to this, the information about the protocol will be there in that. So what does RFC 4301 lists? Access control, connectionless integrity, data origin authentication, rejection of replayed packets, confidentiality, limited traffic flow confidentiality. All these information related to all these is present in RFC. Is that clear? So that's about the services of IPsec. The next thing is there are two modes of communication by IPsec. They are transport mode and tunnel mode, students. Just give me a second. Okay. So the transport mode and tunnel mode, is that clear? So again, very important topic, like how your communication using IPsec will work. So IPsec either uses tunnel mode or transport mode of communication. What is transport mode? Which provides protection primarily for upper layer protocols. Protection extends to the payload of the IP packet. Is that clear? It's not just for the header. The protection extends for the payload of the IP packet also. TCP UDP segment or an ICMP packet. So what is the transport mode is used for end-to-end communication between two hosts. Please keep this in mind. The transport mode is used for end-to-end communication between two hosts. When a host runs AH or ESP over IPv4, the payload is the data that normally follow the IP header. For IPv6, the payload is the data that normally follow both the IP header and any IPv6 extensions headers that are present with a possible exception of the destination options header, which may be included in the protection. Is that clear? So for IPv6, it works in a little different way. In little different way, as I said you before, IPsec is for both IPv4 and IPv6. Okay. So ESP in the transport mode encrypts and optionally authenticates the IP payload, but not the IP header. Is that clear? Keep this in mind. ESP in the transport mode encrypts and optionally authenticates the IP payload, but not the header. Is that clear? So AH in transport mode authenticates the IP payload and selected portions of the IP header also. So that's about the transport mode. So what about the tunnel mode? It provides protection to the entire IP packet. Is that clear? It's not only for part of any packet. It is for the entire packet. After the AH or ESP fields are added to the IP packet, the entire packet plus security field is treated as the payload of the new outer IP packet with a new outer IP header. Is that clear? See, I will tell you how it works. This is what I was telling you about the virtual private networks, VPNs. So how the public internet will not come to know about your connection. For example, I have a packet. In that packet, I have a header A. Is that clear? And the packet is of 150 bytes. So I have a packet with 150 bytes and the header is A. Now that is what supposed to go in the internet. But if you are using VPN, what happens? That VPN software which is running in your system will encapsulate this packet that is with header A into the payload part of another packet with header B. Is that clear? In that case, what happens? IP address will change and your packet will move throughout the internet with that header B. Nobody will get to know that there is a packet in the payload part of this packet with a header B, and that packet is actually with a header A. Is that clear? So basically encrypting, uh, uh, what I can say, encapsulating a packet inside another packet by changing the header. Is that clear? So that's what it means. After the AH or ESP fields are added to the IP packet, the entire packet plus security fields is treated as the payload of a new outer IP packet with a new outer IP header. Is that clear, students? So nobody will get to know. See, if somebody is searching for your data, that somebody will be searching for a packet with header A. Nobody will get to know that there is a packet with header B, which is having that packet with header A. Is that clear? That is what VPN is, and that we call it as tunnel. Is that clear? So there is an example here how the tunnel mode of IPsec operates. Host A generates an IP packet with destination address of host B on other network. This packet is this packet is routed from the originating host to a firewall or security router at the boundary of A's network. Is that clear? Maybe in the default gateway. Firewall filters all outgoing packets to determine the need for IPsec processing. If the packet from A to B requires IPsec, the firewall performs IPsec processing and encapsulates the packet with an outer IP header. The source IP address of the router IP packet is in this firewall, and the destination address may be a firewall that forms the boundary to B's local network. I think it is clear to you now, students. This packet is now rounded to B's firewall with intermediate routers examining only the outer IP header, not the inner one. Okay. So at B's firewall, the router IP header is stripped off and the inner packet is delivered to B. So nobody will get to know that A has sent some data to B. Am I clear, students, about the tunneling?
Yes, sir. Sir, same happens in IPv6 conversion to IPv4, no, sir?
Yes,
That
yes,
that packet is.
yes. That is the same concept of tunneling.
Yes, sir.
We call it as NAT64, right? Basically, address translator from V4 to V6. Okay, or the other way, V6 to V4. You are right. Any other questions, students? Okay, so the next topic, yeah, it's the complete explanation about security association and difference between AH and ESP. We will take this in the next class, students. We will stop here for today. Any doubts? Do you have any questions?
If I'm audible, I can ask the question I was asked
Yeah,
yesterday.
yeah. Yesterday you asked, right? Just a minute. Let me clear your doubt.
I will ask again, or you're checking groups, sir?
I am checking in the WhatsApp group.
Okay.
I've shared it in the group information security, right?
Yes, sir.
Okay, the question is authenticator consists of options okay, the options are timestamp plus session key, timestamp plus client ID, timestamp plus nonce plus
Spelling that one. Yes, sir. Yes, sir.
okay plus client ID plus session key, I think. Okay. Um, mention about authenticator having timestamp.
When in the lecture you mentioned that authenticator will be encrypted using a session key and will be consisting of timestamp. You were like timestamp, like a timestamp found in the authenticator will be incremented by one, and it will be encrypted using session key, and the
Uh,
server will be sending it message via client.
timestamp will
Yeah,
not
that's what you told.
timestamp will not be incremented by one. Nonce will be incremented by one. Nonce is just a random
Oh,
number.
so the answer will be like timestamp plus nonce,
Yeah, yeah,
authenticator.
yes.
Okay, sir. Okay, sir.
So there isn't a nonce in Kerberos, no, sir. We are using timestamp as the nonce for Kerberos, right, sir?
Yes, no, sir, because timestamp is unique. That makes sense actually.
Let me check.
That only I was thinking. But then it is like timestamp.
Let
Yes,
me
sir. So basically, I was thinking like timestamp plus key also be the answer, and timestamp plus nonce. We can probably call that also as an answer because
yeah.
yeah.
Sir, actually
I
during
will
the
check.
class,
Yeah, yeah. Tell me.
sir, actually during the class you told that authenticator consists of client ID and timestamp.
Okay, okay. Let me check. Don't worry. I will check that, and I will, if necessary, I will update it. Okay. Don't worry.
Um,
I because I have not yet seen your marks. I have to check that. Once I am clear with this question, I will update you in the next class, and I will change the marks if required. Okay.
and sir, just one very small doubt. Like directory services are responsible only for storing the digital certificates, na sir?
Yes.
They are not
Yes.
responsible for creating, na sir?
No,
Okay,
no.
sir.
Directory
Yes,
services
sir.
stores. So creating the certificates will be done by another. That is um, AS, not AS. One more I told. I forgot.
CAC.
CA, yes, Certification Authority.
Yes, sir. Yes, sir. Yes, sir.
CA is
Also, sir, last time for computer networks, we were directly given marks, na, sir. Can you give, like, open the feedback in the AUMS so that we can detailedly check where exactly we went wrong?
yeah,
And then,
I will do that one.
yes, sir. Yes, sir. Thank you so much, sir.
Okay. Anything else, students? Okay, so hope things are clear. We will meet in the next class. By that time, I will give you a clarity about that question. Okay. Take care, students. Bye.
Thank you, sir.
Thank you, sir.